Hey everyone, it's Justin. I was asked to do a demo on gauge R&Rs, so I'm just going to go through a example here for you to get an idea, refresher of what we talked about in Greenbelt training. So this file is a unit depth measurement, which is a countersink depth on a super end. So you can see we have operator, part number, and our measurements. Remember, gauge R&Rs, we need operator times part times repetition to be greater than 30 for statistical significance. Here we have 3 operators, 5 parts, and 3 reps for a total of 45. So we're okay there. First thing you're going to do, obviously, is set up your gauge R&R depending on number of operators, number of parts you're measuring. And you record your data, put it into JMP, just like this. Your operator and your part are going to be nominal data. Your unit depth or whatever you're measuring is going to be continuous, so make sure that's set correctly. First thing we're going to do is check control charts. I'm going to go to Analyze, Quality and Process, Control Chart, XBAR R. This window comes up. Our unit depth is our Y, goes in the process. Part is your sample label. That's going to go in there, and then you'll see sample size here, sample grouped by sample label. So now JMP's going to know to group the X bar is going to take these first 3 numbers, do the average of those, that's going to be our point. Next 3 numbers is going to be another average, and so forth and so on. X bar and R are checked. Sigma's 3, that's correct. We should be good. Click OK. Here's our control charts. Remember, on the control chart, we want the X bar R should be out of control for a gauge R&R. You can see the pattern. Point 1, 2, 3, 4, 5 for operator 1, then the same pattern. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5 for operator 3. So that looks pretty good. You want 80% of your data points to be out of control. They are here. And then the range chart should be in control. 1 point's out. Not a huge deal, but ideally you'd want all your points on your range to be in control. Alright, so that's the first check. Next thing we're going to do is go to Analyze, Quality and Process, Measurement System Analysis. This is how we run our gauge R&Rs. This window comes up. Unit depth is our Y response. Part is our sample ID. And our X grouping is our operator. You can see gauge R&R is selected, so that's correct. Main effect is fine. This is all set up. We'll click OK. And now our gauge R&R analysis comes open. This is what initially should come up. You want to go back to your hotspot, go down to Gauge Studies, select Gauge R&R. Okay, this is Sigma multiplier. 6 is fine. If it defaulted to 5.15, just change it to 6. The other thing you want to add is the tolerance. So if you know the upper spec minus the lower spec as a value, you can put it in here. If you want to just put in the spec, just if you're more comfortable with that, change this to LSL and or USL, and now you can put it in. In unit depth case, this is 0.245 to 0.257, upper spec, lower spec. So you'll put whatever part you're measuring, whatever the spec is, this is where you'll put that spec, and you need to put this in to get the precision to tolerance ratio. Click OK. Now we have the gauge R&R opened up, and this is where we start to look at our key factors here for the gauge R&R. First one, percent gauge R&R on the top here, 22.6. 30% is the max cutoff, so anything less than 30% is acceptable. Ideally, this is less than 10 for world world-class gauge R&R. So 22.6 is acceptable. Other thing we're looking at, precision to tolerance ratio, 0.1309. So that's actually 13%. You multiply that number by 100. Precision to tolerance ratio, less than 10 is world class, and anything above 30 is unacceptable. So again, 13 here is a little worse than world class, but still all right. The third thing we're going to look at is discrimination ratio, and to get this, we need to go back to the hotspot, back to gauge studies, and check it here. Now we scroll down, it pops up. So here, ideally, we want the operator to be as close to 1 as possible, and then you have your part. So the ratio here, you divide 6.168, so forth, divided by basically 1. So we have about a 6 ratio here. For here, a 2 ratio, so if this is 1 operator and 2 part, a 2 ratio is about a go-no-go gauge. Ideally, you want this above 4. Here in this case we do. Above 4 is a decent gauge, and anything above 10 is a world-class discrimination ratio. So for our three key factors here, gauge R&R, precision to tolerance ratio, and discrimination ratio, we meet the minimum criteria of those 3 things. So this is an acceptable gauge R&R. And that's about it.